Okay, welcome everybody again to our MakerBot webinar series. I'm joined today by Marco Perry, co-founder of Pensa in Pensa Design, Pensa Labs, Pensa Design. We'll be talking with him about his experience with our printers and specifically, how did you come up with the idea for Pensa? What does Pensa do? Some of your projects. So yeah, with that, let's get started. If you want to talk a little bit about, or tell us about who Marco Perry is, introducing yourself.
Okay, so I have a engineering background and a design background, a little bit of both, and I've worked mostly in agencies. I've held very few jobs. I've tried a lot of different companies, but most recently is Pensa and Pensa Labs. So what Pensa does is it's a product design consultancy. We work with a lot of large corporate that you're very familiar with, the PepsiCos of the world, the Bayer, and a lot of household names, let's say. And then we work with a lot of startups. So we work on physical products, we work on digital interfaces, we work on all the electrical software, whatever needs to happen, we'll put it all together. Mm-hmm. And Pensa Labs is our sort of venture arm where we launch products, bring them up to a certain point, mm-hmm. and then sell them off.
Okay. And just to bring up a quick plug, and I think that you guys also are following our presentation back there. So we have Alison and Matteo behind the camera running the show. Thank you for that. But yeah, overall you've had experience with some of our printers. We'll talk about them in a second. But so just so you know, we have the Rep Plus, the Z18, and the Method, different printers for different purposes. Specifically, I believe you have used in the past the Replicator Plus, and mm-hmm. now the Method. You became one of our beta users. We'll talk about in
and we've had other MakerBot printers.
Right, the 2X as well, right?
Yeah,
you've been kind of a customer of ours for a while.
Yeah, exactly.
Hopefully a happy one.
Yeah.
But before we get into that, I wanted to elaborate on your story, right? How did you kind of came into design? How did you become a designer? Because that's always interesting, like to hear the backstory of big designers, especially somebody who has established himself as a leader in the field and created your own company.
Right.
So yeah, how did you start? And before Pensa, who was Marco Perry?
So I always wanted to be an inventor. Mm-hmm. I think one of the challenges growing up was the feeling that everything had been kind of invented, right? Mm-hmm. So like everything stopped at Edison and that we were kind of done. Mm-hmm. So that's kind of silly, of course. So I went into mechanical engineering school, but at the time the way those things were taught was very much like it was kind of very figured out, and what you were taught was the ways to look things up. It's all by the book. Look it up, right? So if you worked on a power plant, they're like, don't worry about the gears. Like it's really just this graph or whatever. Nowadays, it's taught very, very differently, and they have much more integrated product development programs that are a lot more inventive. So I finished that degree, and I went into a design degree because I thought it would be very creative and sort of to balance it. Also, at that time, design was taught very much all about form, and I think if you made a coffee table that ended up in the Museum of Modern Art, that was
the goal.
Yes.
You made it.
And I was like, no, that's not quite what I wanted to do either. So you kind of have to find your own way. And of course, then when, I'm an industrial designer, nobody's really heard of the word industrial design unless you're in the industry. They're like, we don't design industries. And so like you kind of, most people, especially at my age, they sort of like stumbled into the thing and like, oh, this is actually what I really love to do.
Right.
Because I always loved physical products and experiences,
As a field, industrial design, if I'm not mistaken, it's been around for 50, 60 years, so it's not that old.
The term industrial design was coined by Raymond Loewy from the early 1900s, doing sort of those silver bullet kind of trains when they were first converted from those coal trains with a big stack on the front to those cool ones.
Yeah.
That streamlined look was Raymond Loewy, and Raymond Loewy was like, we design for industries, we're an industrial designer. Should have called it product design, would have been a lot easier to understand.
It's changing to that, it seems like nowadays.
Yeah, we kind of,
And what was kind of like the big, as an inventor, aspirational inventor, what was the big thing that you dreamt on inventing and creating?
I always liked working physically. I always liked working like on gears and mechanisms and linkages. I always really liked that. But then over time, you realize that it's more about the experience than it is about the technology. So before you invent something, you have to sort of decide what's relevant to invent. And so that's how I think in an agency format, you start realizing like, oh, you know what, we have to go out, we have to like talk to people and just find out like what they're doing, what they want, and what really makes sense to them, and then from there you start getting a lot better idea of where to focus your energies, because otherwise it's fun, but we're making Rube Goldberg marble rolls that just so many of those you need in the world.
And you started then working at several consultancies before
one
Pensa.
really. I've had like one job. And then I quit, but it was a great company. It's a fantastic company, like wonderful people. It's just, I think if you have the bug to be independent, you kind of have like no choice, And so I kind of feel like I'm fundamentally unemployable, sort of. I'm sort of, now that that's on YouTube, that's like forever gonna be
forever in the internet now.
Yeah, exactly. This guy's unemployable. No, it's just that you get this bug that you want to try it. There's nothing wrong with what you've learned, but once you say, okay, look, I've capped out on my learning, which is also kind of a silly statement entirely, but you're like, I just want to try it. Give me the wheel.
Yeah.
I've actually given lectures to students called the macro failures of Marco, and it's like once I got the wheel, I did a lot of crashing. But hey, I learned a lot faster, and I had a lot of fun doing it. Nobody got hurt, so.
And how long did it take? Like, so you were in a consultancy for how long, and then how long until Pensa became?
Only 4 years.
4 years. Okay, that's fast.
Yeah, I wouldn't recommend it.
Okay.
I think there's a lot to be said to learning from others and keeping a job. I think that's really wonderful. But what happened was in 2001, the .com crashed. So the nature of the work shifted really quickly, because agencies really thrive on new ideas, innovation, not like next year's product, not the 1.1, 1.2, 2.0.
Yeah.
Those are usually built in-house. Like our biggest competitors tend to be in-house teams, and the in-house team is really working on tomorrow.
Yeah.
We're working like 5 years from tomorrow. So in 2001, when the .com crashed, there was no tomorrow. They were like, we are selling what we have now.
Today.
Yeah. So, the nature of the work changed, and I bore easily. And so it was really no fault of the company I worked at. It was just that I was just like, you know what, if this is going to be what it's like, I'm going to leave. So I left it in April. And then in September 2001, we had another event in New York that really changed the nature of the world. So that was like, if you're going to start a company a couple of months before September 11th, I think it's a bad idea. But who knew?
Yeah.
Who knew? So, I think that actually, in some ways, slowed everything down. The brakes just went, and there was a lot of layoffs, and all those kind of things kind of happened. But what that actually gave me was some time to figure out like what makes sense, like what do I really want to do, and so it took some time with some friends, and we had a space, and this is all pre-WeWork, so we made our own kind of WeWork, and we tried a bunch of stuff, and most of it didn't work.
So that's immediately what created Pensa.
No, did that for like 5 years of like, I was engineering consultant. But it's a really like the unscrew or upper job. Like people would come and say like, we're behind schedule, or somebody messed it up. Can you fix it? Which is not an inventive job. It's a firefighter job, right? So it's not fun. It's lucrative, but it's not fun because it's very high pressure. There's nothing really creative about it. You're just sort of like tamping out fire. So did that for a while, and it did well, and you learn other things that you don't think about when you take on your own business. Like when you take on your business, you think like, I'm good at this, therefore that'll work. People will pay me money. But then there's like, oh, well, you have to, like run a business. And that's, sales and legal. And HR and you got to hire people, and I didn't really know any of that. But my wife did, and so Kathy was working at the same consultancy that I worked at. Worked under the COO, helping grow that company to, like, by the time she left, it was like, I don't know, 8 times the size that when I started. So it grew really fast, and she went through all of that, and it was all through, like, accounting, legal, finance, business, all the things that actually make a business work.
The operational side of the business.
Yeah. So she finished her MBA and said she wanted to start a business. And I was actually ready to throw in the towel, saying, like, this was a terrible idea. No, but she convinced me. So together we started Pensa.
Right. And then what is Pensa all about? Like, let's talk a little bit about the Pensa itself. What distinguishes you from other consultancies? What was the main idea behind it? And
Right. So we consider ourselves a design and invention studio. So that's both a mixture of very creative engineering and creative industrial design. And under the industrial design umbrella, there's all the product strategy, and a lot of times that's UI and things that are digital, of course, now. And on the engineering side, it could be mechanical engineering, but sometimes there's some electronics, there's software, or whatever. But both are creative disciplines that come together. So a lot of consultancies are very deep on design and then strategy, and they go into business and service design, or they go into interaction and software. We always, mostly because I like it, we really push this sort of inventive side on the engineering side.
Okay.
And in our industry, the agency industry anyway, like the West Coast is really known for design companies, and then they have different companies that are the engineering companies, and they outsource to them. We kind of blend the two together here in New York.
Yeah, that mix between the hardcore engineering elements are not super common usually.
It's hard to hire too, because it's oil and vinegar, but you get it right, you got a good salad dressing. So.
Yeah, no, and actually we are going to be touching about on some of the projects that you have developed with Pensa, starting with one of the ones. I think it was the first time I heard about Pensa. When you brought it to the market, that the DIYer, if I'm not mistaken, it was one of the first big successes in Kickstarter. It was funded through Kickstarter.
Yeah,
right?
we funded it one day.
Really?
Yeah.
Wow.
I actually put it on Kickstarter to prove to my staff that we could not fund it.
So it was like proving them wrong.
So
okay.
I guess nowadays you put stuff on Kickstarter, they're making $1 million. No problem. At the time, it was very earlier days of Kickstarter, and so I set the goal at 150,000 or something like that, or 100,000, and I think it was 100,000, and they were like, no, never. And most of the products sold on Kickstarter at the time averaged no more than $50.
Yeah.
And so we put it at $3,500.
Yeah.
And this was all we really shouldn't do this.
And now, did that change your idea on crowdfunding? And
it did. I mean, having gotten a lot of the products to market, especially for the startups, there's a curse of knowledge that this is a very, very painful process.
Mm-hmm.
There's a lot of unknowns. There's a lot of capital going into tooling. There's more engineering than you think there is.
Right.
Doesn't work as well the first time. All those kind of things, right? So we knew that going into that this was not a simple product.
Mm-hmm.
We joke in-house that there's some other design companies that launch their own products. Some of them are like water bottles, and they've done tremendously well. 9-figure exits and all those kind of things. And we always we could have done a bottle. This has got software, electrical, mechanical, and it's hardcore mechanical too. There's it's not just a gear. This whole thing is really pretty complicated. Plus industrial design and manufacturing, and it's capital intensive, and you have to support the software and the firmware. And another company we knew did a spoon, and it was like, oh, spoon.
That's also smart.
Yeah, it was like.
Right.
Spoon's a good idea.
No, and I remember, especially now hearing you talk about this jump between that seems to be people just gloss over that, but we have here the image of the prototype, this plywood prototype with a few
old
gears,
logo
pulleys.
too, and
right.
Yeah, everything. It was all 1.0.
Making that from that into a proper product, and I remember the first time I saw it. It's this sort of almost Dieter Ram's
Yeah,
speaker
yeah.
that bends
Yeah.
stuff around.
Well, one of our designers who worked on it, the lead designer is Peter, so we call him Peter Rams.
Okay, and also like just for people back home, what specifically is this one used for? Because I've used it a lot, but
Well, so the pro version is used for more, dental applications. Like every retainer is made by hand. Every kid gets a retainer. I think there's like 8 million new patients a year. We were just doing spinal implants the other day. We were doing heater coils for chip industry.
Yeah.
We were doing art. We were doing a lot of education. Most of these are sold in education.
right.
Yeah.
No, and it actually reminds me a lot of the process that kind of also with MakerBot, we've undergone a similar flow of the very early stages with the wooden printers, the cupcakes, and then now into a more professional item. So, but the interesting thing here is that you're creating a tool. You're not creating an end-use object or off-the-shelf product, right?
Right. Exactly.
Yeah, that's really interesting.
It's a thing that makes things.
Yeah.
Which is like you guys. We're a 3D printer, but for wire.
There we go. And then here's another one that's I slightly have a slight bias for bicycles. So, but yeah, these the merge bicycle. Let's talk about that one because that's a much more complex object, I'd say.
Yeah, well, this one we also did in house, and it was part of an exhibition for commuter bikes. The Oregon Manifest asked different design companies to represent their city. So they had Chicago, San Francisco, Seattle, Portland. And they chose us for New York, so we were super proud about that. And commuting in New York by bicycle is very different than, let's say, Seattle, because for one thing, it's like very flat. Maybe our tallest hill is Brooklyn Bridge, probably the tallest. But the reality is, our bike lanes are really crowded with double parked cars, trash,
Tourists,
taxi cabs, doors.
Yeah.
And so we wanted something that was really light, nimble, had nothing on it, but at the same time, then you are commuting. You're going to need to bring stuff. So how can you get a light, nimble ride that then turns into something else? We don't have garages. We don't have storage. We have like 1-bedroom apartments. So the idea was could we store everything inside the frame? And so like it has a rack that is the back rack, and you just press a button and it sucks into the top tube. The bottom tube holds a bungee cord that keeps everything on the rack. The front of the tube has a cell phone charger and lights. So everything was built into the frame. Yeah. And so it's only there when you need it, because when you don't need it, you don't want to hit that cab.
Correct. Yeah.
So that was the concept, and the other concept was that we just wanted to make it look like a bike. There's so many bikes out there, especially at the time when a lot of electric bikes were starting to take off. Now they're a lot more common, of course, that they were turning bikes into something that was not what I would consider a bike.
Yeah.
And we thought no, let's keep like the simple, iconic, diamond frame of a bike, but really just transform it for the parts that we want. And this is kind of a good example of like the creative engineering that we had to go into these sort of foldable racks, and routing all of this electrical that then lights everything and everything else, but also the design of just a simple, clean,
right, keeping
bike.
it simple, especially because you think of a bike and it's a fairly straightforward object, right? You had two wheels and a frame, but then making it so that it works, that it complies with all of the requirements that you established in the beginning, kind of that idea of the commuter. And I guess what the images that we have on the right about prototyping, right? How do you actually go about defining the angles, defining the size, the pipes, and you do all of that in-house in Pensa, right? So you have a fairly robust setup.
Yeah, we have a prototype shop that can basically work on anything. And if we don't, we love buying tools.
Yeah, we'll touch on that on the shop because we've been there and it's been quite something to see. And now for the third product, and please, if anybody has questions, Alison is probably running the comments back in YouTube. Do bring them up, and we'll also have a Q&A session at the end. But this one is another interesting one because of the breadth of prototyping that you had to do, even for a small product. This is a razor, right? So,
right.
I don't know if you want to talk about this one.
Yeah, so we're tasked to design the most premium shave that you can get. the reason for the number of prototypes is that basically, if you're one of the large shaving companies, Gillette, Bic, Schick, they're not releasing their trade secrets on how to get a nice smooth shave. And as it turns out, it's not just about the sharpness of the blade or the location of the blade. It has a lot to do with a bunch of little factors that ultimately make a painless shave. Because you can cut hair, but can you cut hair without feeling like you're not also either shaving the first layer of your skin or tearing the hair, or so the problem with CAD is that it has these limitations. It can tell you the weight of the object, but it won't tell you like what does it feel like in my hand, right?
Or you have a few of the prints here,
or it'll tell you the you could do even analysis on the strength of the object, but it doesn't tell you, does this hurt when I shave?
Right.
And I would say that it just took hundreds, if not thousands, of models, and we basically had a rotating schedule of staff shaving in the office. So we put up mirrors, and we had a camera, and we had, we tried different blades, blade locations, exposure of blade, sharpness, all these kind of different things to come up with a comfortable shave. And if you're going to do that, you're going to live and work in a physical world. You need a physical prototype.
Definitely.
And for the first ones, you test it on the interns because you're definitely not going to get it right.
You want to, exactly.
Don't worry about it. If you're applying for an internship, you will not be hurt on purpose.
On purpose, right? Just testing the objects.
Often.
No, but it's an interesting one because it's a simple object. When you think about it, it's the head and the handle. But then having to prototype those with a 3D printer, or actually having the ability, as you say, like to prototype these as a physical object to test them out becomes really important, especially for such a complex object, because it's a small one, but it has a fair amount of detail, right, between these little notch to put the base in, the connection between the handle and the blade itself. How, what's the purpose of the printer? As you're trying to fail a lot and fast.
Fail early and often. Well, look, right now it's 2 parts, right? The first one was probably 12, right?
Really?
But,
okay.
Like it starts out complicated, right? And it's like the old saying, I would have written a shorter letter, but I didn't have the time.
Yeah.
And that's because you have to start with, okay, what I really need to test first is the location of the blade, or the type of blade, or the angle of the blade, or does it need to follow the face or not? What is the weight? What is the balance in my hand? All these kind of things. And right then and there, you're not optimizing. You're solving problem after problem after problem. And each one, you're like, okay, now I got the right blade. Now I got the right location, placement, angle. And so on. Now, how do I hold it? Now, how do I allow somebody to change the blade without cutting their fingers? Right? How do I make it feel safe? Is different from how does it look safe, right?
And behave safely.
And behave safely, right? Exactly. So, all those kind of things you're just incrementally tackling, and each one of these models are tackling each of those things separately, and then ultimately, how do I make it for production?
Right. No, that's just, I think it's a great example, and we'll probably touch back on it on the printers, but
can you show us how it fits together with the stand?
Oh, right. So it actually, you guys designed both the stand and the blade
the
itself.
Package, everything.
So here we have it, the stand and then the blade. These prototypes were printed on the MakerBot method, so it has a different set of tolerances. And we'll touch on that, like the capabilities that you guys have. So the stand, the blade, and just nest it in, which is kind of clean, nice.
Yeah, we wanted the logo to present itself, and we also did. We had different ideas, right? Like should it rest like this on your thing? But then it's inevitably going to be in the toothbrush.
Yeah.
So we wanted something that displayed and looked luxurious, because the first ones of these sold for very high premium. The blades are very affordable.
Right.
And so if you go to onebladeshave.com, I think the blades are much orders of magnitude cheaper than a Gillette, but the shave is better.
Right. And you mentioned a little bit on these iteration cycles, especially, and it's interesting to see like how even a simple object as a blade has so many components on it. Between how do you handle it, how does it cut, the function of it, the actual the storage. So all of these little problems and sub problems that you get to solve as you're prototyping, right?
Right.
And we talked about it a lot here, like where does 3D printing help you the most, whether that be at the initial phase of things where things are a little bit blurry and you're just trying to get a sense for what you're doing, right?
Right.
And then speaking about, us, your experience with method and with 3D printing, I want us to touch on, like, first of all, well, you guys became one of our beta users because you're heavily involved with prototyping, as we said. You have quite an interesting setup in your offices, and you had a lot of printers throughout Pensa's history. Right? So here we have an image of all of the printers that Pensa has.
Yeah, we have another one that's been disassembled now because it's so old.
Oh, really?
No, it's a Stratasys, but they don't support it anymore.
But
like
it's
one of the
interesting
first
to
ones.
see, like, you have anything from, I can see there, like the 2X, the Rep Plus, and now 2 methods.
Yeah.
So how has that experience with the method, being so heavily involved with testing, prototyping physical objects? What would you say about the method? And we have one of the methods right here in the office. But
So
how do you compare it?
A lot of people are familiar with 3D printing, I think, because of MakerBot, right? Because you guys have really made it part of a household name and into the forefront. But, my career, I've been using 3D printing since like the mid-90s, right? Pre-MakerBot. And at the time, 3D printing was very expensive. So it was when you were sure that this was the right idea, then we would get a validation through one print, and it was very precious. As the cost of 3D printing went down, then the use of 3D printing went up, right? So then it starts trickling earlier in the process. So you had that graph of a very messy research and concept process. So when we had industrial grade 3D printers in-house, then we could use them in the engineering validation phases more often than when it was like in the mid-90s, right? But at the time, we were still like, it's expensive material, it's expensive machine time is expensive, power, so on. It was like, we would still be very conservative.
Yeah.
So with the onset of desktop 3D printing, we were trying to push the process much earlier, because if we had the ability to print one thing a day and check it, we would. But reliability is the next question, right? It's like what we were getting out of industrial, and this is maybe like 5 years ago, like what we were getting out of industrial grade 3D printers was the idea that it just kind of works, you don't want to think about it.
Yeah.
And that's super critical, because we never run a project that's got tons of time.
Yeah.
Like, that just doesn't exist, not in my world anyway. So, like, there was no, like, that's okay that it didn't work. We'll just, spend a half day fixing the machine.
Yeah, definitely.
So with the method, though, we get the blend of that reliability and the surface quality and the speed with, which is basically the industrial grade results, with a much more attainable price and cost of parts, so that, the cost of, it's not just cost of machine, but how much does it cost to keep that machine running all the time?
Right.
And, service plans, materials, all this sort of stuff. So with that means that we're going to drive prototyping much sooner.
Right.
Right? And then it becomes something you kind of just don't really think about. It just sort of happens. And so if you need to check something, just print it. It'll be there in the morning.
And what about like the access that your team has for the printers? Are they able to just walk to the printers as they want, and depending on the product, or do you have a queue? How do you manage the access on the printers?
Right now we run a queue. So we actually have these in where we have all our project bays, which is a different room than where we have all the computers. It just that's how our space has evolved. We added this space. So they don't necessarily need to physically be next to somebody's desk or something like that. So it's really handy to be able to just send the prints, and then they check the queue, and sometimes we mess with the queue a little bit if somebody has more of a rush.
Right. Okay. That's interesting. And I think, we've seen a lot of these prints now that you're doing, and we run some of your past prints in the method, like the one blade, because previously, specifically with the MakerBot machines that you had, some of the features were not there, right? You didn't have, for example, the soluble supports that enable you to print more complex assemblies, like the
you couldn't print
the one
that
blade.
head. We wouldn't even try.
this was only available for you guys in your industrial machine before.
Yeah. Also, it's the soluble support is critical, but also the fine details, the thin wall sections.
Right.
It just wasn't going to happen. And like I said, like if it took 3 hours to realize it wasn't going to happen, most of the engineers and the designers, they wouldn't even try. They wouldn't take the risk because they don't even want to wait. You know what I mean? And a lot of times it's not 3 hours. It's like 12 hours.
12 hours.
And then you come back to a ball of spaghetti and you're like, oh, what happened? So, we ended up just running it on the more expensive processes to get to these fine details. Like this head, we wouldn't even attempt it. The base for sure. But
that's
I would say that the Rep 2X was pretty good.
Yeah, I mean that's the thing, right? And we hear it a lot, like especially out in the social media, people talking about, well, yeah, but there's printers that you can sort of manage and squeeze a result from, and we know that with the 2X. I've used the 2X a lot. I used to have a 2X before at my apartment. My girlfriend at the time was not happy about it, but yeah, you can definitely get interesting results with the hands-on desktop, more simpler systems. But then the price that you pay is actually having to manage and sort of babysit the machine quite a bit, right?
Yeah, that's the issue, is that you end up having 1 or 2 key employees that know how to do it. And they become the bottleneck, or they become always asked like, oh, hey, I want this different material or whatever. And they're like, when did I become the printer manager?
Right.
And it's like, and then, things happen, they move on with their career, and you're like, oh, there was the one guy who knew how to run this thing.
And now the printer doesn't run.
Right. There's a big gap between, let's say we have a CNC machine that, machines hardened tool steel, right? That takes skill and training and time, and we know that. And then there's like a printer. But it's hard to live in the middle, right?
Right.
So like our laser cutter, like I wouldn't be surprised if our marketing people can run the laser cutter. It's like it's like, and it just cuts. It's amazing. But if it isn't that, then you need to get something out of the difficulty, right? So we're getting something out of the machining of hardened tool steels that's worth the training. But otherwise, it just doesn't get as much use.
Right. Right. And in your experience, how has Method compared to the rest of your desktop systems?
I would say it's as reliable as or it has been definitely as reliable as our industrial printers, for sure.
That's great to hear, actually.
Yeah.
Now we're excited. And then, I want to keep going so that we get also people some chance to ask some questions. So I'll just do a brief overview of the Method capabilities, where we talked about the PVA soluble support, which is great, especially when you're trying to print complex parts like these razors, because, well, sometimes there's parts and elements in your design that require supports, but once they're done there, you're not able to just ply them out, right? Or you end up, it's possible that if you do, you'll break the part.
Right.
So that one's a great one to use. The fact that it's been tested quite a bit, and now that you guys have also tested it in your facility, so we've logged over, that was the number back in January, 220,000 hours, quite a bit. It's probably closer to 300 about now. And then also, well, talking about the settings and the machines that we currently offer for professionals, it's Method on one hand, our kind of industrial/performance printer, and the Z18, which is our largest one, has a single extruder, so no PVA support there, but great for big objects that you might want to prototype and test out. And of course, Method now shipping, which is great. We're super excited. We've been shipping about for 3 months now. You got your first machine back in March?
No, it was much earlier this year.
All right. Okay.
Yeah.
Cool.
Yeah.
So you've been running it for about 5-6 months now?
Yeah, something like that. Yeah.
Uh-huh.
Unless I'm way off in my memory, but I think I'm right.
No, it's probably right, because we set up our beta testing program a little bit before we started shipping. But yeah, with that, I would like to open it to questions from our audience.
Sounds good.
If there's anything.
Kind.
Right.
Yeah, I think my main question is, when did you start using 3D printing regularly in your design process?
I would say at least 97.
97.
96, 97.
So that's 30 years worth of...
yeah.
Oh,
yeah.
no, sorry, 20 years worth
They
of...
were very expensive. It was mostly SLA.
Uh-huh.
And then it was Z-Corp printers, and then filament printers.
Do you remember how much you paid for your first print?
Oh, they were like crazy expensive. They were hundreds and hundreds of dollars, if not thousands of dollars. I remember one time we did this like little button, and it was like a little switch, but we did a inches to millimeter problem, and we got like a 25.4 times the size button, and we were freaking out because it was like. That was like $2,000. We have to throw it out.
That's
you know.
Whereas this one, like something like this, is probably what, like $2 maybe.
Yeah, it's like
ish. I don't know. Do you even account for the material cost?
We do. Yeah. But we track everything.
Yeah.
You know, but that's just a part of the business. But as it becomes less important because it costs more to track than it does to try to recoup or anything like that. But you know, you could go nutty. Like you could start printing stuff when you really hadn't taken the time to think through the process of whether this was a good idea first or not. So there's always going to have a little bit of tension of like, are you sure this is the right idea?
Right.
And then in that vein, what are some of the like big ideas that you tossed around during the one blade prototyping?
Oh, we had all sorts of, you know, it started with business model ideas. I would say that they were very wide on how to redefine shaving entirely. And then from there was a bunch of different business platforms of which to go with. And then there was like the research on the blades. And the challenge is that you can make an incredibly sharp blade, but that doesn't mean it's comfortable. And we're not entirely, I mean, we were with micrographs, like, you know, like super high power microscopes, looking at these things, and you can barely tell the difference, and the comfort level was very, very different. So there's more research to be done there as to why, but once we found the one that really, really worked, we weren't going to go any deeper. But there is, honestly, I'm still not entirely sure as to what it is, and a lot of it is very, very coveted secrets.
Right. And how long was the development process of one blade as a whole?
I have to guess, probably 9 to 12 months. I would say most products take about 18 months.
Yeah.
That is just our general, I don't care what you're making, it's going to take 18 months.
Yeah.
You know?
Okay.
But, and everybody says we'll do it in 12, and they get it done in 18.
Okay.
Who knows?
Yeah, well.
A lot of that is not our time. It's like manufacturing and all sorts of other things outside of our timeline.
Well, I think that with that, I'll cap the questions, and thank you again.
Thanks so much for having me,
Marco. Thanks everybody out there. If you have any further questions, we always are happy to hear them. Our email is hello@makerbot.com. But yeah, I mean, hopefully we'll be seeing you more in the future and knowing more on what you guys are doing in prototyping with the methods now.
Yeah, love it.
But thanks for taking the time, and thanks for joining us today.
Yeah, thanks for having me.
Yep. Thank you guys, and see you next time.